Welcome, everybody. Greetings from Oaxaca. As you know, we're operating Osmocom-based networks in various communities around the northern Sierra of Oaxaca State and in the western part, known as the Mixteca. And let's see how this is going to work out. You can also feed back to me a little bit about how the screen sharing is working out, if you like. There's a monkey. This you've probably seen before. Anybody who was present at OsmoDevCall when I showed this little thing, which was a creation of mine that, as you can see, I'm not really a graphic designer, but let's just make this a little bit bigger. So you can see this is like pulling live statistics from each of these sites. And the one with the monkey is simply not responding at the moment, possibly because the internet is out at some point in connection to that particular village. But let's take a look at what kind of data I've got here on one of these communities, for example. So let's take this one, Via Alta. Some interesting data here is that this is the number of mobile handsets currently connected to the network, 464. Number of SMS messages in the queue currently waiting to be delivered, 1,270. There is actually currently one call in active call right now. And what else we got here? This is kind of interesting. Recent edition, we have 364 successfully created MM contexts on the 2G data side, and only 22 PDP contexts. So out of these 464 telephones that have connected, 364 of them are either data-enabled phones or for some other reason have, well, obviously they're data-enabled phones, but it could be, I noticed that, for example, these chocolate bar old phones that have limited data capacity will ask the network for an MM context when they connect. But they would only bring up a PDP context if you actually went into the menu and hit the web browser thing, or alternatively on a more modern smartphone, only if you have data turned on, if you get the PDP context. And we have communicated to people in the communities to say, do turn on the data, it's working. And I still see these very low numbers, so I'm not really sure why that is. Hard to know without going out there and seeing exactly what's happening with the phones.
If I can have a comment there very quickly, maybe roaming disabled and MNC doesn't match in your normal use case?
Yes, of course. That's also been communicated to people. It's been emphasized a number of times that because of the fact that we're using the SIM cards that they have in the phones, they're not going to match the network code, and so everybody is essentially roaming all the time as far as the phone is concerned. And as we all know, Android and other devices will pop up that warning to say, beware, you're going to spend a lot of money. And we told people to make sure to turn on the roaming data option. But it's quite possible that that's one of the reasons why. So that's about that's about all I can say about that for the moment. If I click on it, it'll refresh. So we now have 2 active outgoing calls. We've got a little tortoise here telling me that the latency round trip time to our SIP infrastructure server is a little bit high. So although the latency in itself is not a great indicator of voice call quality, what we tend to see is that when the latency is high, we're also going to have rather high jitter, which does make it sound.
So can you explain how these values are taken or obtained?
Sure. I mean, this is the number on the left is actually it's just running ping every 5 minutes or so and updating a file, which is then read in by this. So the letter on this, the figure on the left is the round trip time to the WISP data center, the provider for this particular site here in Oaxaca City. And the second figure on the right is the round trip time over the VPN to our data center where we route the voice over IP calls. So it's just simply running I think I'm counting ping with a count of 4 or something like that, and then averaging the round trip time, writing that to a temporary file and reading it out whenever I click on this.
I meant more for the other data, like this PHP script is just like using the control interface toward OsmoMSC or what?
No, it's actually calling well, let me see, how can I explain that? Okay, let's take a look at, okay, let's move away from that site because it's a little bit slow. Let's go somewhere that's a little faster right now. This one. So this is the sort of administration interface for, okay, there's a little bit of private data there. Okay, people's names. Okay, well, it's on screen now. This system gets its data from a RESTful API, which if I call, I think statistics. No, I forgot what it is. Stats. Oops, no, that's not good. Okay, let's go back here and take a quick look at the console. How to debug stuff. And just take a quick look at what is the URL that those things are. Well, we can see it here in Firefox development tools. You can see that we called. No, I can't. It won't move. Okay, whatever the URL was, it's calling this RESTful API, which is just spitting out this data here as a JSON, which is then read in by this JavaScript running here and updates all of the data in this little box. So as for what's happening behind the scenes, when I call that, what do you call it? Well, when we refresh this page, we'll getting here the load average, just calling load average in the system. These things come from accessing the FreeSwitch console and getting some data there. Here we just have the uptime, which is again just a system call to uptime. This data comes from analyzing output from FreeSwitch. Then there's some things here that are accessing the database of our call records and SMS records. This data here, for example, is kind of the idea with this is to help somebody look and see is there something, how's everything going on the network? Is it everything look okay? So this is telling me that in the last hour, there were 100 SMS messages sent, and that the average number of SMS messages sent over the last 6 hours was this number here, 142. So it kind of matches. On this site here, we could see, for example, that in the last hour, there's been this figure, 767 messages sent, but the average over the last 6 hours was 581. So it looks kind of normal. If you would see, for example, 10 here, maybe, then you'd say, oh, okay, maybe something's happened with SMS delivery. The same goes for this. This is the number of calls in the last 10 minutes, the number of calls in the last hour, and the number of calls over the last day. You can see that there's currently 3 local calls in here happening, 5 incoming calls, and 1 outgoing call. So does that, I guess that answers the question. Vadim is asking, is it Osmo MSC's internal SMSC? Yes, although this site here is running Osmo SMSC, or sorry, Osmo MSC. This site here is still running the Osmo NITB. So, but let's not talk about that too much. There's one other interesting thing we can do here is click on the number of TRX. Yeah, still running the Osmo NITB. Close that one. So this is something that's been more and more useful. Just being able to quickly check if we get reports from people about bad radio coverage. We can ask them to make a call, or indeed call them, or indeed bring up a silent call via the Osmo MSC and take a look at the radio levels. The green line here is make this a little bit bigger maybe. Green line here being the neighbors, uplink and downlink, and we can see that in this case, this person, I'll just make it a little bit smaller so it's not jumping around the place so much. So in this case, this person is close enough to the tower to be able to that their uplink strength is high enough that we're actually able to reduce the power of transmission from their phone. And if I just make that a little bit smaller, you can see here for each new traffic channel that that comes into existence, this number will increment. So if I leave this page open for a while, I can get some idea about how much traffic is actually happening on each BTS. You can select here to filter and only show traffic channels. It can be quite interesting and a site that's a little more busy. This one has 6 TRX. So here we can see neighbor reports from another physical site. This one here, meaning this is the slave BTS in the light cell one. So here you can see the neighbor report from the master. And then this is another physical site, which is some kilometers away. And as the person is moving around, we can see that the measurement reports from the other site are actually coming and going from the noise floor. Let's take a look at what we've generally got going on. We can see our Osmo stack running. And I have a number of like one-letter commands that the things that I type all the time, aliases and stuff that I've set up. So This one will bring up a tmux window with sngrep on the top and the free switch console on the bottom. The free switch console will show things like the status of the free switch profiles and, for example, current channels that are in use. And this is the data that gets parsed, and we extract, extract interesting data and send it out to that statistics reader. So here we have a call incoming from one of our SIP servers into the system here. And this is the 5295198000620 would be the DID number assigned to this particular village. So when that number is called, FreeSwitch will answer. We can scroll back there, we can see that FreeSwitch answered the call and played back a message that says, welcome to the community, so please enter the 5-digit number of the mobile handset that you want to communicate to. So here we can see receiving the DTMF tones that this person entered, followed by the hash key, and then FreeSwitch proceeded to send that call to the Osmo SIP connector, and the phone answered. You can see that there's 2 legs to that call here, this being the first SIP invite coming in from the data center, and then this is the B leg of the call to the Osmo SIP connector. And you can turn on the RTP display, and we can see that it's using the AMR codec. It's showing me unassigned here because actually the Osmo SIP connector does not respect the dynamic payload type that FreeSwitch sent to it in the way back. So you can investigate that a little bit here. For example, now if I change the size of the tmux window while sngrep is showing me this window, it will crash. So I'm just gonna do that and then go back in here. So we can see the STP here, that in the STP that, sorry, wrong leg. If we look at the STP that FreeSwitch sent to the Osmo SIP connector, FreeSwitch decided it would use a dynamic type of 98 for AMR, and Osmo SIP connector decided to use 112, which is out of spec. It should have respected the initial dynamic payload type that the user agent that initiated the call decided to use. So that's why sngrep here is showing that one of these RTP streams is actually an unassigned type because it's reading their type 112. FreeSwitch doesn't seem to mind. Yeah, there may well be something that can some configuration parameter to fix that. Although I have an idea that maybe not. Actually, what's kind of also happening here is that I forced FreeSwitch to use type 98, even though it wouldn't if you install FreeSwitch from distribution packages. But either way, I think that the Osmo SIP connector should respect the initial invite. So anyway, you see a few other things happening here. These are, as an example, local calls from a local number on the system. This was a call originated from Osmo SIP connector here on the local IP to the FreeSwitch. FreeSwitch sent the B leg back, and the result was busy. That's that, I guess, those things. Get out of there, because otherwise sngrep will run. If I leave it running for a long time, it will actually run out of memory and get killed by the out of memory.
Just one question regarding FreeSwitch. Is it the new FreeSwitch from new repositories or something old compiled yourself?
This is FreeSwitch 1.10.3 running on this site at the moment, which is a few months old, maybe. I was following the FreeSwitch development since they went to version 1.10, and but some weird things started to break in it, like some very strange stuff. For example, you can set these session parameters before you bridge a call, and suddenly it started crashing with one. Can't remember which session parameter it was that I was setting. So I've started actually migrating the sites back to FreeSwitch 1.8 because I sort of have the feeling that a lot of this new development on FreeSwitch has to do with things like maybe Big Blue Button that we're using right now, which I believe has FreeSwitch in the back end. So a lot of video stuff, things that we don't really need. FreeSwitch 1.8 was very stable. Also 1.6 actually was very stable for us, and no real features that we need have been added. We also don't have any public access to these FreeSwitch. They're not available on any public internet IP. So from that point of view, we consider ourselves safe in terms of the fact that there's no open public access to this FreeSwitch. So if there was a security issue or some security bug, we'd probably be able to get away with that. So I would probably downgrade the FreeSwitch on all the sites soon down to 1.8 because it's easier than staying on top of the current head of the development. And if I want to install a new system, the packages for this particular FreeSwitch that we were looking at here, which was what 1.10 something, are not available anymore. So I would have to install the latest one, and then I'll have to check everything. So I will go back to 1.8. We can take a quick look at something else. So we have a data center actually in Dallas, Texas, that is running all these virtual machines, which have been around in existence for quite some time now. Some of them are still running old Ubuntu versions. So you hackers out there, none of them are really internet facing either. So, but it is a task to upgrade a lot of those. So you can see these names here of the VMs all have to do with cactus that are used to make mezcal. Well, not all of them, but the original ones is Madre Quiche, Monocots, Papalome, Tepestate, Tobala, Tobasiche, Verde, Arroqueño. Those are all names of magueys that are used for making mezcal here. We kind of ran out of names of magueys. Espadín, of course, the famous one, and ended up using some other names like Git, which is actually not running. But for the machine that is the main SIP VoIP server was called Amazonas, but then Amazonas had a problem with the disk mirroring and got copied to one called AM at the time, and AM then just ended up remaining running and never got its name changed to Amazonas. If you take a look at SNGrep activity here, you see quite a lot of calls coming in and quite a lot of spammers trying to see if our SIP system will accept their registries, and lots of people trying to constantly make calls. I believe that one of the things that happens with this is that when one of these SIP probers will find a SIP server somewhere that will actually let them make calls, they call pay for what do you call these, like services that when you call them, somebody receives money for each minute that you're on the call. So they just call those numbers and then they get paid. So most of the traffic comes through this SIP server. We used to run the RTP actually over the VPN, but I've recently stopped doing that because I'm feeling that we're actually getting better performance by running the RTP over the public internet, which means that it's not encrypted. We're not using SRTP here. The upstream provider doesn't actually support it, but well, that's what it is. So this side below is like what's happening on the VPN side, and this is the public-facing internet public-facing interface on the top. And it's not particularly busy right now at this time of the day. It's 1:45 p.m. here in the afternoon, 1:45 p.m. So it gets it's quite busy around 6, 7 in the evening. These screens will just fill up as soon as you open it. So this server is running Camelio. So when an invite comes in here, it's Camelio that is responding to it. And then Camelio will look up its table based on what the destination number is, and then it knows where to send the call to. Sorry, actually what we have here is an outgoing call. So by the other side, when somebody in the community calls a number, it will get sent over the VPN. Again, Camelio receives the SIP invite, looks at the outgoing number and decides which upstream provider to route the call to. And we'll see it go out on the outgoing interface. In the case that sometimes we are using, let me see, just take a look at some of these. Okay, so this one is running the RTP over the VPN. So we'll see the RTP there. So we'll transcode from AMR in the local free switch in the community and send G729 here to the data center because G729 will be accepted by the upstream provider. If we sent the AMR to the data center here, we would have to transcode in the data center, and then we'd be transcoding all the calls in the data center, which means that we wouldn't be able to send them directly from the communities to the provider in the case that we do bypass the VPN, if that makes sense. We also have some communities that are on VSAT links. And in that case, we have a SIP server called SEMS, which is muxing all of the RTP streams into one UDP stream to avoid the UDP overhead. Then there's another SEMS server that runs on the community side, which will demux those streams and send them out to FreeSwitch on the ports that FreeSwitch is expecting to get them. So that helps us to get more concurrent calls onto the VSAT link. And there's another server that does that, so which is actually in the data center of the satellite provider. I don't think there's any traffic on that server right now. We could take a quick look and see. I can remember what it's called. I think that will get me in there. Yeah, I don't think we're probably not going to see any traffic on that right now. But this server again is running SEMS, And just to repeat that, SEMS will receive the call, and it will, if it doesn't already exist, it will bring up a tunnel to the across the VSAT to the site, and tunnel the calls over there. Okay, so there we go. There's an incoming call there, so we'll see the G729 come across there. If we look at the B leg of that call, we don't see any RTP because the RTP is tunneled in that SEMS tunnel that I was talking about. You can also see that we got various 200s from the remote site because of the latency on the sat link. The Camelio, or sorry, the SEMS in this case, didn't receive the 200 in time. So, or no, sorry, the other side, the community didn't receive the ACK in time, so it sent the 200 again. I may be, so I'm probably a little bit too familiar with SIP myself at this point, that maybe for some people who aren't used to looking at SNGrep and looking at SIP transactions, this might be a little bit too fast or too much, but that's what that is. Okay, well, I'm going to go debugging that right now. Okay, so something else I thought might be interesting to see. Some of you saw that photo earlier on, but now on the video recording, this is one of the sites in the Mixteca. It got installed recently, and this is our installation crew inspecting the base and the area around the tower. Somebody commented earlier also, keeping the growth down and facilitate access to the tower. So the Ericssons, the RBS system, I think this is possibly one of the only BTS houses running an Ericsson RBS system that actually has its own toilet. I think this house, or this outhouse where we installed this system, actually used to be a jail. It was where they used to lock the bad people up for the night when they misbehaved. So I think that's one of the reasons why it has its own little toilet bowl in there. There's no water in it, but there's a toilet. This is our more or less still in process of being installed. You see the rack of batteries here. Battery charger, and hidden behind the bar here, there's a converter and voltage regulator. You can see it there. So this is, as you can see, we have this do not connect the serial port here, because this was where we had this problem of the negative 48 volt rail on commercial telecoms equipment. So the computer box here is also being fed with 12 volts from a converter, this converter here. But there's a 48 minus 12, I think, or even there and abouts, potential difference between the ground on the PC case and the ground on the everything else, basically. So even though the battery rack was essentially electrically isolated from everything else, we still had, I don't know, voltages coming through the wall or something. And so we had DC potential voltage difference between the ground rail on the PC and the ground rail on the Ericsson unit, which meant that at the time of connecting the local maintenance terminal serial cable, well, we fried the ground pin on there. So we need to make sure that's opto-isolated in the future. This is a system which is local here in Oaxaca in the office. This was with an easy way to just get some cooling on the roofs was to put this big old room ventilator on top of the rack, which sat nicely there actually. Blows quite a lot of air down top of the roofs and keeps it cool for the short amounts of time that we tend to turn this thing on for testing. So this one is that's what it looks like at the moment. We have connected to a tower on the roof, which looks like this. This is something of an experiment. I'm no RF engineer myself, and I consider it sort of magic. I even though when you look up, how everything should be, and what your power budget is, and what your losses are, and what the antenna specifications are, as far as I can make out, it never really works out quite like that in the real world. So this is something that we're testing in order to be able to have a back-to-back coverage areas. These are, I think these are 90-degree antennas. So this is the feed from the Ericsson below. This is a tower-mounted amplifier, and then the output of that is just running into this splitter box here and splitting into both of those antennas. And that seems to work quite well, given that there's way more power in the Ericsson Rust than we actually need. We don't have any real problem with splitting that power output into two antennas. And then on terms of the uplink, running the uplink into the tower-mounted amplifier and back down to the roofs also seems to work. So this is our little TMA there. So I'm actually a few blocks away from this unit. So if it's a slightly older picture, but okay, the picture. So if I can just remotely power on those units that we were looking at. And then let's bring up just take a look at the spectrum here locally. I hope this doesn't outdo our bandwidth capabilities for moving images on the video stream. So we should see in some short amount of time. We can also take a look at our BSC. I don't know if you can see this font size on the terminals.
Looks good.
Okay. So we can take a look at our TRX situation. The Ericsson at this point will be doing its thing, warming up its clocks. I've no logging going on this Osmo BSC terminal right now. Actually, we could. Okay, so we're still seeing lost link from Ericsson RBS 2000. So it'll do that for a little while.
how often do you see this mismatching channel number? Because to me it happens when Osmo BTS starts, but for some reason fails to establish the RSL link, or I don't remember.
I think I know what that is. I think the reason for that is because the BTS is locked. So just unlock those. Actually, I can leave a second. Well, okay, unlock both of those, and then just drop the. There's also a new RAN light cell connected here. Actually, we can. Which was that other picture? That new RAN light cell 1.5 is also connected to a small patch antenna on the top of the tower. So, yeah. Okay. Not seeing any RF yet.
It's a bit like nano BTS that also takes time to actually start transmitting.
Yeah, the new RAN, there it goes. The new RAN light cell will ramp up. You can see it ramping up there, I imagine. RFCAN 249. But the Ericsson hasn't come up yet. Let's just wait a little while for see if I would expect it to kick into action shortly. Of course, because we're doing this live, anything will happen. Precisely what you don't want to happen. Okay, well, while we're waiting for that to happen, I can also take a look at the Ericsson OMT, assuming that it actually has booted up okay. We should be able to establish a serial connection to the unit. Yep. So we have this constant line here between, this may be a little bit small for you guys to see, between the GSM node and. Yeah.
Is that software from Ericsson?
Yep. So once we have the GSM node connected here to the OMT program, we can load up its IDB database, which will read the database that's running on the Ericsson DUG, the DUG, the digital unit GSM. It will, okay, it's comparing the hardware it's detected with what it thinks it should have. And once it's done that, it will tell me that, okay, we've got a DUG, we've got a RUS, and we've got a TMA. It doesn't really know actually that the TMA is there or not, other than that I've told it it has one. And I still don't see any transmission from it. We can start a monitor on the radio unit. I looked at this morning, and I did actually notice that it's telling me that the VSWR is not possible to monitor, which means that it hasn't started transmitting yet.
There is a little warning sign on the bottom right corner of that Ericsson program.
Ah, yeah. It's looking for its power supply units and its the entire rack that you've seen photos of what the Ericsson RBS unit looks like in a real Ericsson installation. And then you can see in our photo here that all we have is the DUG itself and the RUS. And then, well, actually the DUG is inside that other thing that I don't remember what it's called, which has fans at the back. But it's also expecting to find climate control units and power supply that it can monitor. So those warnings are because it can't find those things.
I also have some question from the images before. So you had like lots of packs of batteries. Is that just like because there's no AC and you need to charge that, or just like if there's some outage, or?
Yep. In the installation pictures that I showed, this one.
Yep. Yes.
So yeah, this is our AC input here on the right-hand side of the Samlex power unit, coming from the commercial electricity provider, 110 volts AC. So with that, we charge the batteries, and then the hope is that when that power goes out, we don't have power from for whatever reason, it happens quite a lot, especially in the rainy season, that these batteries will power the entire system for some hours. So that'll be powering the entire Ericsson system here and the PC that's running the Osmo stack.
Okay.
Well, here we go. Because we're trying to do this live today, the Ericsson's not coming up.
Are we gonna see a live investigation with a GoPro camera? What's actually happening in the physical setup?
Yeah, I wanted to install some cameras in the office so that I could take a look at the thing, make sure. What I consider might be actually happening here is that I saw the SWR was quite high this morning, much higher than it was the last time I did any tests, and maybe some wind or some rain or something has changed or moved something on the tower. So it's possible that the reason why the transmission won't come up is because actually the SWR is too high. But you could try just turning it off and on again. It should tell me that the connection has been lost. It'll take a moment. Okay, I'm going to power it on again. Far too much of that. Okay, so there's the light cell coming back up. Okay, notice the disconnection. Let's reconnect. I guess I may not when you. Okay, so the Ericsson is responding now. And we're seeing fault reports from it, which again is probably it's just complaining about the lack of climate control units and such things. You need to reload the IDB from it. Take a look at the TRX. Still locked. Oh, well, that's a shame. It worked an hour ago. Okay, well, let's for the just getting a little bit. Yeah, we should have some more colors on the VTY. Maybe not. I don't know about green though. What else could we do while waiting to see if this thing is actually going to come up?
Did you test DGSM already?
Yeah, but I don't have it really running anywhere that I can demonstrate right now. I mean, it's the HLRs that are running on the systems that are running the split stack are they're configured for as DGSM servers, so I could query them, and it works. Oh, it looks like something there. Did it come up? Yes. Okay, so let's lock the new RAM. So we can see that the Ericsson is now telling us that it's unlocked and it's okay. So we should be able to check the monitor here to check the SWR there at the RF port, and it should tell us that. Okay, so it's, as you can see, it's a little high. It's 3. Don't like that at all, but nevertheless, you can see it here. And hopefully what's going to happen now is that I can actually register a phone from where I am. Okay. So then I'm going to go back to this window here and take a look at the monitor. Hopefully, when I place a call, you can see my signal strength monitor there. And if we go here to the Ericsson configuration, we can actually, in real time, change the configuration of the TMA. Actually, I want that there. What I want to look at here is the uplink measurement from my phone. And if we change the TMA type to externally powered, essentially turning off the power that's on the RF line to the TMA, we can see that our uplink drops right down to minus 110. The call is actually still active and operational, but it's right in the noise floor. So if I turn on the power to the TMA again, we go up about 10 dB, which is more or less what it's supposed to be. So my hope is that this configuration is going to work for us, splitting 20 watts of output power from the RUS into those two antennas, and then using the TMA to boost a little bit for the 18 to 20 meter cable run that we have from the tower down to the unit. If I, for example, unlock the new RAN, there we see the new RAN came up on the, and of course we handed over to the new RAN, which worked from an RF point of view, but the audio didn't follow because that's actually not implemented. The media gateway is unable to switch from the E1 interface to RTP. It's something that needs to get implemented. So in terms of that, call has lost its audio now, and I can't really have it hand over back to the RUS. So I'll just hang it up. And I'll turn off that equipment because I don't like that SWR3. So that's on my Ericsson RBS demonstration, which is just for anybody who might be interested. I'm actually operating in licensed band there. This little piece of the spectrum on the right-hand side of the top end of the 850 band. Is licensed to TIC. You can see some pretty powerful 3G going on there in the band. Quite interesting. There's not an awful lot of 2G here in the 850. They're mostly running it in 1900.
Can you explain what's that SVWR you were talking about?
The standing wave ratio. I wonder, is anybody here in the group who might actually do a better job of explaining SWR to me? I could just say that it's the reflected power coming back from the antenna. So we're pushing RF energy out onto the feeder line from the roost unit, where's the picture of the roost?
Okay, thank you.
So we're pushing a lot of RF power out this line here, which goes out through the hole in the wall and up to the antennas. And for some reason or other, we're getting rather a lot of that RF power getting reflected back down the same line, which is not good from the point of view of stressing the amplifier, but also because it will maybe interfere with the downlink. Although again, RF to me is like I don't know. I talk to RF engineers and I can never get straight answers about things, and I can never really figure out, why things are not operating as they should be according to the theory. You have a power budget, you're transmitting so much power, your antenna has X gain and it's pointing in such and such a direction, and you actually go to that place, and then you don't get the performance from it that you were expecting. Yeah, that's right. An SWR of 1 would be a theoretical ideal. There's some pretty simple graphs and information on SWR if you search on the internet, for anybody who's listening. We do publish this recording. You might be interested. Or just ask an RF engineer. There is something else I wanted to show you. Yeah, definitely want to show you that. Okay, so let's see what the connection is like to this place right now.
Of course, our lovely CSN1 parser. How could we forget about it?
Yeah, so I see quite a lot of this, and I think this is pretty much the last of the CSN stream decoder errors that I'm seeing a lot.
There's a ticket for that already, right?
I think so.
Yeah, there was a ticket, and there was a few messages actually that causing the errors to show up. But I guess it's one of them. And if you look at the specification of this message, then it's really not clear. Like the specs themselves look weird, and it seems that different phones may be implementing the message itself in a different ways. And I don't really know how to fix it properly. So one of my ideas was to actually have nano BTS. You can connect to a special port and tune the logging messages and get the decoding results of the CSN1 streams. So maybe we could see how the IP access guys decode such messages and then try to fix it somehow. But that would require one of the phones that actually produces the messages, because so far I have never seen anything like that. So that's it.
Yeah, well, as you can see, I have quite a lot of them out there on that site, and it's quite common. I mean, I'll see it pretty much anywhere.
Could you identify a specific model so we could probably buy one and try to investigate in the office?
Yeah, I mean, I guess I could. I did send a PCAP with this CSN error, right? I guess I could capture.
But I mean, we don't really need a phone. It's just like a pickup file should be enough to get basically the hex string of what's being sent, and then we can look at it.
Yeah, I mean, Vadim pretty much figured it out before, as far as I'm concerned. I think he nailed it actually. But I didn't quite understand. There was some reservation about it. Maybe
actually,
I think the theory was that the spec is wrong. Sorry, go ahead, Vadim.
Specifically asking for the phone because, like, if we have a PCAP, we cannot send it to Nano BTS. Like, we don't have open source UPRS implementation to do that, unfortunately. So if we have one of the phones that actually produces such messages, then we can easily reproduce it and see how commercial BTS handle it, and then we can try to fix it. So the thing that what you actually need to do is basically match the TLLI with the identification process during the TBF establishment, or actually during the PDP context activation. And then from that, you can probably identify the IMEI, and from that, the exact model.
Mm-hmm. Yeah, I'm going to try to do something like that. I also, maybe of interest, just to show you, is that where I'm actually running one SGSN. So on this machine here, so one GGSN, all the SGSNs are communicating over the VPN to this, so which sometimes does seem to expose some problems with when that communication is interrupted. And this is a quick list of all the IPs, PDP contexts from which SGSN they're coming, and the associated IMSI, which was just me really screen scraping the VTY of the GGSN and formatting it a little bit pretty. So you know, I can maybe do something like choose one at random there. This see what happens. A lot of the time they won't respond. I mean, some phones, oh, there you go, 5 seconds bring up time, and coming down there a little bit more to 600 milliseconds, 6 seconds again. So I find, you know, some, of course, some phones just don't respond to ping, the actual OS in the phone itself. And then for other reasons, like these phones may have moved out of coverage since they established their PDP context or such. I guess we could also look at something like this and get an idea of what kind of traffic or what kind of throughput we're seeing there. Nothing. So as I said before, I kind of set this up as an instant messaging service only. So because most Android phones, at least, and also of course Apple phones, will try to contact their relevant Play stores or app stores or whatever it is, looking for updates and all kinds of things and all kinds of data that the phones will constantly try to phone home about. So it's pretty limited to what's actually accessible. And what I've done, what I used to do was I used to blacklist certain domains. So I run a DNS server here also on the GGSN box, and that DNS server was blacklisting domains. I also redirect any DNS requests because Android phones will mostly use the DNS server that's given in the DHCP from the GGSN. But then if they find that they can't reach it or they can't resolve a name they want to resolve, they'll just fall back to the Google DNS. So I trap that traffic and redirect it to the local DNS server, and then blacklisted those domains. But I changed that recently because I realized that they don't back off ever. They just keep trying. So it's actually better to let them resolve the names they want to resolve, and then deny the traffic. That ends up creating less traffic on the network, on the radio side. That you're interested in seeing.
If there are any questions that you want to be recorded, yeah, feel free to ask them, and then we start recording in a few minutes.
Maybe it would be a good opportunity to like explain where do you have the different stuff that you've been sharing. I mean, the code and like all those lovely scripts that you use to like get quick access to stuff or lock or unlock stuff, or the web platforms or this kind of stuff.
Sure. So most of it is okay. So when we looking at this live monitor again, just to get an idea of the different communities and villages that we have, which we hope again this year to expand quite a lot. Of course, I don't want to be individually changing things on a large number of systems all the time. So the whole thing is run by Puppet. So any scripts that I push out are all pushed out by Puppet, and the Puppet repository is available. It is actually online at gitlab.tic.ac.org. So you can find for example, if you're familiar with Puppet, people might be a little bit more familiar with Ansible, but basically kind of the same thing. Yeah, where is it? Oh, it's not there. It's here. So just said I have a shell function file that is in the gets dropped into etc/profile.d, and there's just a bunch of functions. For example, this one that starts a tmux server and then SSH into every BTS connected to the system and gives me a nice 2 or 4 pane system as we saw here. Actually, I think I left that running today. Yeah, this one. So in this case, there's actually 5 BTS connected. So one of them is a Fairwaves UM site. There's also other scripts in there that allow to do things like run a command on every BTS. And there's these scripts like PDP, just list the PDP addresses that are on the local SGSN here on this system. Just to check also the what does NS stand for in terms of that? Communication between the PCU and the SGSN. I don't remember. And of course the famous VTY script that I use to attach to the different daemons and also set logging or not at that point, so I don't need to type enable, logging enable, and all of these things. All of that stuff is generally somewhere inside the Puppet recipe. Here's the lock and the unlock scripts. Just again, avoiding having to type, telnet 4242 and then enable and configure terminal and go to network and go to the BTS and then lock or unlock it. It might not be terribly obvious if you're not familiar with Puppet as to where to find those things, but if you explore it a little bit, I mean, you can always clone it and grep on it.
And the live monitor application is the one I read as MEAS Web or something like that, also in this GitLab?
No, this is MEAS Web, which is something originally developed by Fairwaves. And I've added a little bit to it. I'm actually working on something else to put under here at the moment, which is going to be like a channel usage meter. So when the BTS gets full, we'll have a little meter going into the red that all the channels are getting filled up. But was hopefully going to be ready for this demo, but it's not. But yeah, that's also in there in MEAS Web. I'm not actually sure if all of these repos that you're seeing there are public. Okay, so MEAS Web is public, yeah. If anything isn't, of course, you can always shout out to me on IRC or drop an email. If we do end up out on a video, you can email me at keith@rhizomatica.org. I was using GitHub and GitLab and all kinds of things for Git, and then in the last year or so, I just stopped doing that and decided to use my own infra. This GitLab is running on the other side of a DSL connection, so it's not in a data center or anything. So you could probably find that it would get very slow if you are trying to clone a large repository from it or something like that. So again, maybe if there's any problems with that, feel free to get in touch. But thanks very much for listening, everybody.